and morning. This is the second day of me making a verbal contract with my students to make a short video every day. Alright, so I'm doing the first series is going to be on algebraic proofs because, well, you guys don't like them. So I've put a question up on here. I think it's a 3 or 4 marker. It's been a bit vague. But that gives you about 4 minutes. So what I suggest you do is stop, have a go at it for 4 minutes, and then start the video again. Right. So I'm assuming you have or you haven't, either one. Whatever, either one. So let's have a go at this. Prove algebraically. So, and again, this does not mean, and I say it all the time, with an example is not proof, right? That the difference between the squares of any two consecutive odd numbers is always a multiple of 8. Now, I haven't done this before. Well, if I have, I can't remember. Alright, so the kind of thing that I focus on is odd numbers. And I'm going to go from the top, and the way to really think about odd numbers is, first of all, to understand what even numbers are, algebraically. So what I tend to think of is when you do nth terms when you're all little, and is 1, 2, 3, 4, 5, and these are my positions. So 1, 2, 3, 4, 5. So I've got to kind of think, well, how, I don't want just one number. So if we put down, the value here, if this was even, it'd be 2, 4, 6, 8, and these are basic sequences. If I wanted to create an nth term, and an nth term is a rule, and it's a general rule all the time that takes all my numbers at the top here and converts them, changes them, modifies them to the numbers at the bottom. So, well, how would I do that? What is the rule? Well, the rule is I'm going to just double it. I'm going to times it by 2. So, times it by 2. And I know that a lot of you are going to look at this and think, do you know, that's really simple. But I like to do it from the beginning. So, we don't write times. So, the general term, we would just write an nth term, it would be 2n. So, if I want an even number, it is 2n. Well, we've got to think about odd numbers. Well, what is an odd number? When it comes to odd numbers, I kind of have this in my head. And then I think, well, what can I do to these numbers to make them odd? Well, I've got 2 choices. So I'm going to put even numbers up here. So they're odd, I've got 2 choices. I can either take an even number, which we know is 2n. I can either add 1, or I can take an even number and I can minus 1. Either one will get you to an odd number. Technically, I like the 2n minus 1 because it includes the number 1. So my first term will be 2 times 1 is 2, minus 1 is 1, and that's an odd number. However, I kind of use 2n plus 1 quite frequently because mathematically it's easy to manipulate for students because you kind of, and I'm generalizing here, mess up with the negatives. Alright. So that's that part there. So my odd number is 2n plus 1. And then it says 2 consecutive odd numbers. And then we've got to kind of think about how odd numbers or numbers work. So if I've got odd numbers, I'd be going 1, 3, I don't know why I put a comma there, 5, 7. So I want 2 consecutive numbers. So if we start with 3, well, that's easy, my first number. So I'm going to ignore that because I'm using 2n plus 1. So if this is my first one, so this is 2n plus 1, well, how do I get to my next odd number, which is here? Well, actually, I've added 2. Yeah? So, it would be, if I change this one, it would be 2 times 1 is 2, add 1 is 3. So 2 times 1 is 2, add 1 is 3. Well, I want 5. So I'm going to do 2. This is my second term, times 2 is, what am I doing? No, that's silly. I would just add 2, alright? So it'd be, I want 5. So how do I get from 3 to 5? I add 2. I like that, I got a bit of silliness in there. Add 2. So 2n plus 3. 2n plus 3. That will be my next number. Right, so 2 times 1 is 2, add 1 is 3, 2 times 1 is 2, add 3 is 5. So there are my 3, 5. And they're consecutive, one after the other. You want this number to change because it's one after another. It can't be any odd number. So you can't change this, the variable there. Right, so it's the 3. So my two consecutive numbers are odd numbers, are 2n plus 1 and 2n plus 3. All right. So, so I want to, the difference between the squares. So I want to square these, right? And I want the difference. So if I write that out first, 2n plus 1 squared. And what I want the difference. So what I would do is I would take the biggest, which is obviously going to be this because I've got a 3 in it. So I take the biggest, 2n plus 3 squared. And I would take away the smallest. All right. That gives me that. So at each time, so I'm kind of messing my layout, and this isn't the best way to be. It's just me, and it's really hard to change those kind of things. So this is the kind of thing you have to deal with. If you're, messing with your layout, you have to kind of make it semi neat as possible because you lose marks. So I'm going to deal with this one first. All right. So I'm going to expand the brackets two different ways. So the first one, I'm going to do this one, is the tradition FOIL. 2n times 2n is 4n squared. 2n times 3 is 6n. 3 times 2 is 6n. And 3 3s are 9. Alright, so I'm just going to move across here. So I can simplify this down to 4n squared plus 12n plus 9. And what I like to do, at this point here, I like to put square brackets. Right? And I'm going to now expand my second bracket. And I want the difference, so the difference means take them away. So at this point here, what I would do is expand it in a different way. And I actually quite like this for younger students. Just be careful. And I should mention that. There's some, when you first start and you're in year 10 or year 9, looking at this, you kind of think, 2n squared, that'd be 2n squared plus 1 squared. It's not. It's, what it actually means is, as I wrote it out last time, it just means 2n plus 1 times 2n plus 1. Right? Just be careful with that. Right, I'm just going to remove that, and this is another way of expanding, a slightly different way of expanding double brackets. We'll end up with the same place, 4n squared, 1 times 2n is 2n, 2n and 1. And then you simplify them. 4n squared is 4n squared. Put square brackets. 2n add 2n is 4n. And I got my plus 1. Don't like that. So what I'm going to do, I'm just going to tidy this up a bit. I'm just going to take my expansion of brackets here. Hopefully that's got it all. I'm just going to move it across. I left a plus there. Alright, so I'm just going to, come on little plus. Just delete this plus here. And I'm going to put that plus back up there. Let's just move back. Let's give ourselves some space. So that's my 4n plus 1. Now I like having these big square brackets, and the reason being that I know this is minus, and if you really want to think about it, this is minus 1 times everything in there. So I'm going to write it out again, 4n squared plus 12n plus 9. And now I'm going to times everything on the inside by minus 1, or I'm just going to flip it. However you want to look at it, really doesn't matter. Some teachers say you times everything by minus 1, some teachers say you flip everything. It really isn't relevant because it gets you to the correct answer. So now when I look at it, you've got minus 4n squared and 4n squared. These two cancel out. You've got 12n minus 4n, which is 8n, and you've got 9, take away 1, which is 8. So we've got 8n plus 8. If we look back at the question after all this working out, it says always a multiple of 8. So all I do now is coming back to this 8n plus 8, is I just factorise that by 8, n plus 1. That's it. This shows that it's always, no matter which number you pick, it's always a multiple of 8. Anyway, that's me done. It's 8:35. I've been banned from the computer too early. So now I'm going to do my work. Right, darlings, have a lovely day. If you've got any questions, leave it in the comment section. Bye-bye.